11.2 has a lot of material in it. We're going to start by just going over some definitions for curves and polygons. A simple curve is a curve that does not intersect itself. It can start and stop in the same place, but it doesn't have to. If we look down at our examples down here at the bottom, then A is a simple curve. B is not simple because it crosses itself. C is simple. D is simple. E is simple, and so is F. Notice some of them start and stop at the same place and others don't. Next, we have a closed curve. A closed curve is a curve that must start and stop at the same place. And for the intersection, it can intersect itself, but again, it doesn't have to. So you can be simple, closed, or both of those. Looking back at our examples, A is not closed because the shape itself isn't closed inside. B is closed. C is closed. D is not closed. E is closed, and so is F. So you can be simple, closed, or both. Next, we have a polygon. A polygon has to be both simple and closed, and the sides have to be line segments, so no curves. If we look down, we're only looking at the simple and the ones that are closed, so C, but it can't be a polygon because it's got the curves. Same thing for E, it's all curvy. So F is my only shape that is a polygon. And polygons have vertices or vertex, and it's a point on a polygon where two of these lines meet. So F here has a lot of vertices. Another way we can classify shapes is calling them convex or concave. A convex shape is a simple closed curve. It's convex if the segment containing any 2 points on the curve is contained in the curve. It's a little bit easier to look at than to write out as a definition. Think about making a line segment go across this oval. That line segment would be inside my shape, so we call it convex. For B here, if I made a line segment over here on like the mouth or the opening, it would be on the outside. We call that concave. You can think about it being a cave, like where a bear lives. This was a circle and we caved in part of it. C is convex. D is concave because of my 4 caves. If I made a line segment connecting these 2 points, it would be on the outside of my shape. And E is tricky. It's actually neither one of them because it isn't closed. It should have to be simple and closed. To write out that definition of concave, it has to be a simple closed curve if at least one line segment that we're writing, those line segments containing 2 points, is on the exterior of the curve. Another common concave shape is a heart. And most of our shapes, when we think of like squares and rectangles, triangles, those are other examples of convex. Moving on to polygons in more detail. Polygons are classified by their number of sides. This is also going to be equal to their number of vertices. So if you have 4 sides, you're going to have 4 vertices. A 3-sided polygon is called a triangle, and a 4-sided polygon is called a quadrilateral. That word doesn't get used a lot. We're going to see there are different types of triangles and quadrilaterals in class. There's squares, rectangles, parallelograms. A 5-sided shape is called a pentagon. A 6-sided shape is called a hexagon. A 7-sided shape is called a heptagon. An 8-sided shape, a lot of people remember, it's an octagon, like an octopus. That OCT, the prefix, means 8. A 9-sided shape is called a nonagon. A 10-sided shape is called a decagon, D-E-C-A, deca, meaning 10, like decade. And then past that, we call them n-gons. So like a 17-sided shape doesn't have a special name. We just call it a 17-gon. To name these polygons, we name them with capital letters. And those letters are written in consecutive vertices. So I've got my quadrilateral here, and I'm going to call it A, B, C, D. So we're going to go in alphabetical order. Don't switch around. That's what we mean by consecutive. We're going to be talking about their angle sum. The interior angle is on the inside of the polygon, like use interior paint for the inside of your house, and exterior paint for the outside. Now the exterior angles are a little different. They don't go all the way from one side to another like the interiors do. Instead, imagine taking one of the sides of your polygon and extending it out. Kind of like an imaginary line there. It's not really there, but we can imagine extending it. The exterior angle goes from the side to this imaginary extension, so not all the way around. Diagonals of a polygon are these line segments that go across the polygon, or we say they connect two non-consecutive vertices. Just a fancy way of saying they go across. If they were consecutive, that would be a line segment and not a diagonal. And last, we have regular polygons. These are convex polygons, so no concave guys. And what makes them special is all the interior angles are congruent, and all the sides are also congruent. So if you think about a square, all my sides are the same length, and that's what these little dashes mean. It just means I'm congruent. And all my angles are 90 degrees. Also could have an equilateral triangle. All my angles are 60 degrees, and my sides, again, are equal. You could have regular anything. You could have a regular hexagon or a regular decagon. They're just a little bit harder to draw, and we're a little bit more familiar with these guys.